System of equations, addition method. In this video, we'll talk about solving not one equation, but two or more. And that's called a system of equations. What I'm going to assume in this video is you can solve a single linear equation in one variable. So something like 2x plus 3 equal to 7. So you subtract 3 from both sides first and then you divide by 2. So that's a two-step equation that you can solve for one variable x. So if you're not sure how to solve something like this, there is a video on one and two-step equations. So be sure to watch those videos first. But here I'm going to assume that you're good with solving one variable equation. Now in this video, we'll focus on more than one. So we'll start with two variables and then we'll ask how can I solve for both of those variables. So when it was one variable, I used the letter x. For two variables, I want to have x and y for the variables. And there are several methods, and one of them is the addition method, which we will talk about in this video. So what I'm going to do is I'm going to say I have one equation in two variables. Say x plus y equal to 5. Now, when you have only one equation but two variables, you cannot solve this because there won't be a unique solution. Look, 1 plus 4 is 5. So 1, 4 is a solution. So when you say x is 1, y is 4, you can write this as an ordered pair where the first number would be x, second number would be y. Now there are other solutions too, like 2 and 3. 2 plus 3 is 5. Now you don't have to have just positive integers, you can have negative numbers. So 5, 0, so you can have 0, or you could have 10 minus 5, 10 and negative 5. So as you can see, there are tons of solutions. In fact, every point on this line, if you were to graph this, you get a straight line, and every point on that line will be a solution. So there will be infinitely many solutions. So you cannot find a single solution for both variables. But look at this example. I'm going to have the same equation, x plus y equals 5, but I'm going to write one more equation. Say x minus y equal to 1. Now call this as equation 1, this is equation 2, and notice, now 1, 4 will work here, but it won't work here. So we have to come up with something that works for both equations. And rather than guessing, we will have some methods to solve. One of the methods is the addition method. As the name suggests, this works when you can eliminate one of the variables, when you can get rid of one of the variables by simply adding. So if you were to add these equations, now let's go ahead and draw the line through both equations. And if you were to add, x plus x is 2x. And the plus y minus y, they cancel each other out. So then you don't have anything in y. 5 plus 1 is 6. So when we added these two equations, the variable y was gone. So now we have only one equation in one variable. You just divide both sides by 2 and you get your answer, x equal to 3. All right, but this is just only x. We only solved for x. So this is not our complete solution. We still have to find the value of y. So call this as equation maybe 3. So if you plug this value of x into one of these two equations, I'll use the first one. So I'm going to write down plug equation 3 in equation 1. Then what do you get? So plugging means you replace x with its value from equation 3. So I'm going to have x plus y becomes 3 plus y equal to 5. And how do I solve for y now? I subtract 3 from both sides. So I get y equal to 5 minus 3 is 2. So this is my other half of the solution. So what's my answer or what's my solution? My solution consists of this: x equal to 3, y equal to 2. So this is my answer. I could have written this as an ordered pair. So sometimes you'll see a solution for two variables, x and y, is written as an ordered pair, where the first number would be x, second number would be y. And you can check that 3 plus 2 is 5 and 3 minus 2 is 1. All right, so that was an easy example. Let's look at one more example. Example 2. Now I'm going to say I have 2x plus 3y equal to 5 and negative 2x plus 4y equal to 2. So just like the previous problem, let's number those equations, call them 1 and 2, and again draw a line through those equal signs. And again, if you were to add 2x minus 2x, they cancel each other out, but 3y plus 4y is 7y equal to 5 plus 2 is 7. So I can solve both sides by dividing by 7 and I get y equals 1. So this is my equation 3, and I'm going to plug equation 3 into one of the two equations, but I'll use equation 1 because this has a negative sign and it's better to avoid negative signs. In equation 1, then what do you notice? Equation 1 is 2x plus 3y. 3y means 3 times y, but I'm not going to write 3y. I'm going to write 3 times 1 because y is equal to 1, is equal to 5. And then I have to simplify this equation. 2x plus 3, 3 times 1 is 3, equals 5. And this is a two-step equation, so I'm going to solve by first subtracting 3 from both sides. And then I have 2x is equal to 5 minus 3 is 2. And I divide both sides by 2. I get x equal to 1. So what's my solution? My solution is x equal to 1, y equal to 1. Or I can say 1, comma 1. All right, let's look at the next example. Here we are given this equation: 2x plus 3y equal to 8. And now I'm given x minus y equal to, say, negative 1. So when I try to solve this equation, now if I were to add directly, I get 3x and 3y minus y is 2y. So I will have both variables. So that's not good. In the previous two examples, when we added the equations, one of the variables was gone and we only had one variable. This is the kind of situation we want to be in. So this time, since I don't have opposites, Why here the x variable was gone is because I had 2x minus 2x. But I don't have anything like that. Here it's 2x, but it's not negative 2x here. Here it's 3y, and this is not negative 3y, it's negative y. So what I can do is I can multiply this equation by 3. That's same as saying multiply both sides of this equation by 3. So let's rewrite our equations. The first equation we did not touch. It's 2x plus 3y equals 8. And now the second equation becomes 3x because it's 3 times x minus 3y is equal to, remember, we are multiplying the entire equation by 3. So be sure to multiply 3 with negative 1. You get negative 3. So these are your new equations. So equation 1 is the same as the old one, but equation 2, we complicated it a little bit because we wanted to have plus 3 minus 3, plus 3y minus 3y. So we can carry out the addition. So now we are ready to add. 2x plus 3x is 5x. Plus 3y minus 3y cancel each other out. And that was the whole point of multiplying by 3 to get that negative 3y instead of having just negative y. And 8 minus 3 is 5. Perfect. So divide both sides by 5, you get x equal to 1. So this is half of our answer. And the other half, so call this as equation 3. You want to say, I'll plug equation 3 into one of the equations. And my choice is equation 1 because it does not have any negatives. All right, so you plug x equal to 1. So equation 1 is 2x, but 2x is 2 times x, but x is 1. So I'm going to plug it in. X equal to 1 is plugged in here, plus it's 2x plus 3y. So I have 3y equal to 8. All right, now I have only one variable. I have to simplify and solve. 2 times 1 is 2, plus 3y equal to 8. Subtract 2 from both sides. And 2 minus 2 cancel each other out. So I have 3y, and 8 minus 2 is 6. Divide both sides by 3. So let's do that. You get y equal to 6 divided by 2 is 3. So you get y equal to 2. So once you have solved for both x and y, you're good. Then you can write down your solution. So your solution is going to be 1, 2. Be sure to write x first and then y. Okay. So in example 3, we could not directly add. We had to multiply one of the equations by some number, and then we could have, we could add, and the solution method worked. Now sometimes you may have to multiply not just one equation, but 2 equations. So let me show you that example as well. So say I have 2x minus 5y equal to 4, say, and then let's say this is 3x plus 2y equal to 25. So notice, if you multiply, you don't have opposites. You have 2x, you don't have minus 2x, but you have positive 3x. You have negative and a positive for the y coefficients, but this is negative 5 and that is positive 2. Now, if you multiply the second equation by any integer, you cannot get 5. And if you multiply 5 by any integer, you cannot get 2. So what I need to do is I need to multiply both of these equations. So I'm going to turn the 5 and 2 to some number. Now I can turn them both into a 10. How? If I multiply 5 by 2 and 2 by 5. Notice. So when you do that, here you would have negative 10y and here you would have positive 10y. And then you can cancel the y's. So you want to think ahead as to what numbers you got to multiply. And generally when you multiply by the other number, that's good. And you just need some practice to tell which numbers to multiply. So let's go ahead and multiply. The first equation becomes 2 times 2 is 4 and x minus 10y equal to 2 times 4 is 8. And the second equation becomes 5 times 3 is 15x plus 5 times 2 is 10y equals 5 times 25. That's a big number, but the answer is 125. I know that because 5 quarters is $1.25. So 5 times 25 is 125. So sometimes thinking about money will make math easier. All right, so let's call this as equation 1, equation 2. Now we are ready to add them because we have opposites. 4x plus 5x is 19x. Minus 10y plus 10y cancel each other out. So there's no y, which is what we want. We don't want two variables here. 8 plus 125 is 133. And you divide both sides by 19. And 133 divided by 19, you can use a calculator for that. On the left side, it's just x, and right side becomes, this is 7. So that's our partial solution. Call it equation 3 and plug equation 3 into, now this time I want to use equation 2, old equation. So it's 3x plus 2y equal to 25. So I'm going to have 3x is 7 plus 2y equal to 25. So let's simplify this. 3 times 7 is 21 plus 2y equal to 25. And be sure to draw the line through the equations. That way you can keep the left and right side separate. So you have to solve this. It's a two-step equation. At first you subtract 21 from both sides. Then 21 minus 21 cancel each other out. You got 2y equal to 25 minus 21 is just 4. And then you divide both sides by 2. You get y equal to 2. So that's your solution. So your solution is x equal to 7 and y is equal to 2. All right, so these 4 examples showed us how we can solve two equations in two variables. Sometimes you may be just able to add, but sometimes you may have to multiply either one or both equations by a suitable number, and then only we can add and you'll be able to solve. Now, there are situations where when you solve, you won't be able to solve because you get something like 0 equals 0 or 0 equals 1. In that case, you have two other possibilities. So let's look at example 5. So say I have Let's take a simple example. X plus y equal to 3, and say I have negative 2x minus 2y equal to negative 6. Now notice we don't have opposites. We have x, but we have negative 2x. So if I multiply this first equation by negative 2, what do I get? The first equation becomes negative 2x minus 2y equal to negative 2 times 3 is negative 6. And the second equation, oh, wait a minute, I should have only multiplied by positive 2. So, sorry about that. This was positive 2. I needed the opposites. So it's 2x plus 2y equal to 2 times 3 is 6. And then you have negative 2x minus 2y equal to negative 6. Now you want to work with these two equations. Now notice what happens when you try to get rid of one of the variables. 2x minus 2x, they cancel each other out. But 2y minus 2y, they also cancel each other out. So on the left side, we have nothing but 0. And on the right side, we have 6 minus 6, which is also 0. So 0 is equal to 0. We don't have any variable. When we try to get rid of one of the variables, both variables are gone. Now, when such a situation occurs, you say that, and you get a true statement. So if you are getting 0 equals 0, you say there are infinitely many solutions. Because these two lines are nothing but the same lines, so they meet in infinitely many points. However, there is one other situation where you have no solution. So let's look at that. And again, let's keep the first equation, x plus y equal to 3. And now, let me say the second equation is negative 2x minus 2y equal to negative 5. How about that? So this time, like in the previous problem, I'll multiply the first equation by 2. So first equation becomes 2x plus 2y equal to 6. So this is equation 1. And equation 2, I'm not going to change that. It's negative 2x minus 2y equal to negative 5. Now when I'm adding these two equations, and again, let me draw my line through the equal signs. 2x minus 2x cancel each other out, and 2y minus 2y, they also cancel each other out. So I have only 0 on the left, but on the right I have 6 minus 5 equal to 1. Now when I try to get rid of one variable, I got rid of both variables. So there is no variable here. I don't have either x or y. But I ended up with a false statement. 0 is not equal to 1. But I'm getting this equation, 0 equals 1. So if you get a false statement like that, then your answer is no solution. You cannot have a solution when you have a false statement. But when you have a true statement, you have infinitely many solutions. So there are three kinds of problems. You can have a single solution, a unique solution, like in the first 4 examples. That means these two lines meet at this point, 7, 2. Or they may meet in infinitely many solutions. When you have the same line, then those two lines are coincident. They meet in infinitely many points, so that's why you have infinitely many solutions. Now what's happening here? Here the lines never meet, which means they are parallel. So this is the case. For example 6, you have parallel lines that never meet. For example, 5, you actually have only one line. So if I want to draw two lines, I'll have to draw the second line on the first line itself. It's the same line. And what happens here when you have a unique solution is those two lines meet at this point, 7, 2. So that's the idea. Now, in this video, we only talked about a method to solve, and that method was the addition method. We will learn about more methods and also talk about what's the point of solving a system of equations. But we need a lot of practice. So I have these practice problems. So do your best. The first problem says x plus 2y equals 7, and the second problem says 3x minus 2y equal to 5. Okay, and I think everything else is clear. So sometimes you may be able to directly add, and sometimes you may have to multiply one or both equations by a number. And as always, I have the answers to these practice problems in the video description. So good luck with that, and I'll see you in the next video. Thank you.